Hey, I'm Charlie Thompson, and I wanted to do a really quick video showing the formation of recessional moraines and how they're different from terminal and end moraines. So here we've got a typical alpine scene. We've got snow falling, it's accumulating, the snow's getting compressed, the air's getting squeezed out, and it's becoming glacial ice. So once it gets a couple hundred feet thick, that ice will flow downhill under the influence of gravity very, very slowly. Maybe, a meter a day might be a good rate of flow for you to keep in mind, which is like 3 feet a day. So it moves really slowly, but it does move under the influence of gravity. So as the ice is moving along, it's moving over the ground and it's picking up rocks, it's disturbing rocks, it's transporting rocks. So you've got abrasion and scouring on the bottom. And when the glacier sits in one place for a while, so when conditions are such that the amount of snow coming in is matched to the amount of heat and melting in the wintertime, you can have a situation where the glacier is still flowing downhill in this process. So we've got a glacier, it's flowing downhill, and it doesn't look like it's moving because the end is staying in the same place. But as the glacier is moving along, it's picking up, these are erratics, it's going to grind those against the ground, and it's going to build up at the end, making, in this case, this would be the end moraine. This is the terminal moraine because that's as far out as it got. So here we've got a terminal moraine. So in this case, the glacier has flowed downhill. There's a cool and wet period when the glacier is advancing. And now conditions have changed. Maybe it's warmer. Maybe it's not as wet. And so there's less snow coming in and there's more ice melting away. And so what's going to happen is the glacier is going to keep flowing downhill, but the end is going to stall out for a while. So now we've got the formation of a recessional moraine. So this would be the terminal moraine. That's the farthest moraine out. This would be the end moraine. And as the glacier melts back, this would be a recessional moraine. So now we've got a series of recessional moraines. And what that tells us, when you have a series of increasingly smaller recessional moraines, that tells you that the first sequence, the first part of glaciation was the biggest push of the ice downhill. So it forms this nice terminal moraine here, and then as the glacier melts back, it stalls out for a while. You get a recessional moraine, it melts back some more, you get another recessional moraine. And so the only way you can end up with these subsequent smaller recessional moraines is if the first push was the biggest, and then it melted back, and you got a smaller one, and it melted back more, and you got another one. So the other thing that could happen is the opposite, where you could have had a series of recessional moraines, right? You could have had a small pulse and then it melts back, and then a bigger pulse and it melts back. And when you get that bigger pulse, what happens is all the previous moraines are going to get shoved, they're going to get transported to the end, so you end up with one big, huge, massive terminal moraine. So if you have one moraine, that tells you that the last episode of glaciation was the biggest because it's moved all of the evidence of previous smaller glaciers. It's just shoved all that to the end like a bulldozer. On the other hand, and this is the situation in the Sierras, when we had a larger or colder, wetter conditions, a more extensive glaciation. The glaciers were larger, they were longer, they flowed farther downhill. And then we had a series of smaller glacial episodes where the glacier wasn't extending as far out. And so you get this series of recessional moraines. So just to summarize, if you have a series of smaller episodes of glaciation and then a bigger one, all you're going to end up with is the evidence of the last one because the loose rock is going to get pushed to the end, and then you've got one end moraine or one terminal moraine made up of jumbled moraine from all of the smaller glacial episodes. On the other hand, like in the Sierras, we've got a series of recessional moraines, and then the organic material in these moraines we could use to radiocarbon date and go, oh yeah, in fact, this is the oldest, this is more recent, and this is the youngest. So I just, like I said, wanted to make a really quick video to explain how you end up with a series of recessional moraines as opposed to ending up with just one big, long, massive terminal moraine. That's it. I hope you enjoy the lab.